Hello, my name is Harshal and this is my student ID. In question 2.4 and 2.5, we are demonstrating a TCP session hijacking attack. TCP session hijacking is one of the most powerful network attacks, unlike the TCP reset attack that we demonstrated in question 2.2, where we simply terminated a connection. Session hijacking allows the attacker to take the control of the TCP session and inject their own malicious commands, making those server execute those command as and it makes the server believe that it came from the legitimate user. The attacker works by sniffing network to capture a TCP packet from a victim session. And from this packet, the attackers extract the sequence number, the acknowledgement number, and later, after extracting that, it crafts the forged TCP packet with those exact values and injects malicious command into the data field. The server then receives these packets and believes it came from the legitimate victim and executes the injected command. Uh, in this demonstration, we will create a file named s420774.txt, which will contain this is my name Harshal text. Second, we will hijack the telnet session between the victim and the user. Third, we will inject a command that sends file content back to the attacker machine using netcat. Fourth, we will display the file content on the attacker's machine and hijacked and prove that hijack was succeeded. Our network will have four machines: the attacker, victim, user 1 and user 2. We will not be using user 2 in this attack. First, let me verify if all the Docker containers are running. So Docker PS, yep. As we can see, all the four containers are up and running. Uh, the assignment also requires me to create a file named after my student ID and it contains my student name. So let me show you the file that actually has my student ID. So home Harshal dot s420774 which .txt, which is my student ID, and it says this is my name Harshal. This file also exists on user one at home seed s4207, which is where we will hijack the command, which is where the hijack command will read it from. So docker exec execute it user one 10 point so user one slash 10.9.0.6 uh, cat slash slash home slash seed and our txt s420774.txt file. So yeah, uh, it reads this is my name Harshal. This is available on the Docker container. Now I will show you the hijacking script that I have written, the Scapy script. So it is at cat, I guess it is in home directory. Yeah, it is in home directory. Cat slash home slash Harshal Harshal hijack. Yeah, hijack order.py. Yeah. Here first we have imported everything, every Scapy tool, which gives us Scapy gives us like access to network packet crafting tools. That is what we have imported. Second, we have defined a callback function that is automatically called when every packet is captured by the sniffer. Secondly, if TCP in packet this line, we check two things. First, that the packet has both TCP layer and the raw data, uh, which means that it actually contains data. Second, it has the destination port of 23, which is the telnet port. We only want to hijack packets that contains the real data and not empty acknowledgement packets. Here we are printing the captured packets along with their source IP and the destination IP. Uh, and at IP here, we are creating a forged IP header using the same source IP and the destination IP as the capture packet. This makes our injected packet appear from it came from the victim machine, and user one will have no way to tell the difference. Here TCP, it has the source port, our destination port, and flags is set to acknowledgement A. Uh, the sequence packet here, this is the key for like successful hijacking. We take the sequence number from uh, captured packet and add its length. This gives us the next expected sequence number, the exact value user 1 is expecting to receive next. If we use any other sequence number, user 1 will reject our packet. Third, we will have our acknowledgement packet. We copy the exact acknowledgement number from the captured packet. This is the malicious command we are injecting, data bcat. Uh, this reads the file that we have, the that has my name as I shown here. Yeah, this is my name, Harshal. The NC1, the NC thing, sends the output to the attacker machine at 10.9.1 and at port 9090. The R and A is actually the ones that are returning and are capturing to the new line by simultaneously pressing that. It makes the shell execute the command when user will receive the packet. So when user will receive the packet, we will assemble and send the forged packet. The return true stops the sniffer after the first successful hijacking. So the sniffer listens at the bridge interface for TCP packets from the victim user 1, and the count is specified to once, which means that it will stop capturing after hijack has captured once. Now let me start the telnet server on the user machine. So docker execute /it user 1 10 point sorry 10.9.0.6 service open bhd service open bhd I netted start. Oh, we have not done. Yeah, user 1 slash, yeah, that's what I was missing, I guess. Yeah, as you can see, we have started the telnet server. Now on the first terminal we will actually start the netcat listener on the attacker. So here it goes, nc/lvp 9090, that is the port we are listening on. On the new terminal we will establish the telnet session between the victim. So docker exec/it, I guess it was victim slash 10.9.0.5 slash bin slash bash. Now we will also start our telnet server, telnet 10.9.0.6 seed and these. So yeah, uh, the telnet session is now established. The victim is logged in as the user 1 and can now run commands. We will need to run the hijacking script, but first I guess we will just open our Wireshark and make sure that it listens to the source and destination IPs we want here. Now let's go back and just run the Python script, the Scapy script that I showed you. Sudo python 3/home/Harshal hijacked auto.py seed. Yeah, the attacker is now actively sniffing the network waiting for any TCP packet from the victim to the user 1. The moment it captures one, it will inject the malicious command. Now I will trigger the hijack. I'll just go to the victim telnet terminal and press enter to generate a TCP packet and trigger the hijack. The moment the victim's machine sends a TCP packet, our script captures it and it shows captured sequence. Yeah, let me show you. This is what it shows. And it also immediately injects here First, let us analyze the hijack script output. So we switch to the hijack terminal, and this is where the captured sequence, the exact sequence, the acknowledgement numbers were captured from the victim's packet. Hijack was sent. The forged with our injected command was sent to user one. The entire hijack happened in milliseconds. The user one received our forged packet and executed the command, thinking it came from the victim. Uh, Let me show you the file content on the file content on the netcat. So, connection received on 10.9.6 and our port was 1990. It also had this connection on 10.9.6, the user request, and the contents of which are displayed now. This proves that the session hijacking attack was successful. The attacker injected into commands telnet session. The command was executed by user one, and the file content was sent back to the user's attacker's machine, all without the victim's knowledge. Let me also show you the Wireshark to confirm the injected package now. Yeah, as you can see, the Wireshark see the source IP is 10.9.5 to 10.9.6, and it also see you can also see the correct sequence number that the user was expecting. Sorry, the user was expecting next. The injected command is happen to be in the payload here. In order to summarize, the TCP session hijacking attack has succeeded because TCP has no source authentication on any machine, uh, and the network can send packet claiming to be that it came from the host. Second, the sniffer actually captured the exact sequence number from the victim's packet. This is the critical value that makes the user one accept our forged packet. Third, we calculated the next expected sequence by adding the data length to the sequence number, sequence plus length plus data, ensuring the user one accepted and injected packets in the sequence. The injected command cat home seed that has my name, sorry, the my student ID as 4207724.txt was executed by user one as if it came from the victim. The file content was also, this is my name Harshal, was successfully displayed here via netcat. This attack demonstrated that why telnet is fundamentally insecure. Not only the attacker can sniff all the traffic including passwords as we have shown in question 1.2, but they can also completely hijack an active session and execute like commands on the server without the legitimate user knowing anything is wrong. The defense against this session hijacking is to use SSH instead of the telnet. SSH encrypts all the traffic and cryptographic sequence number that cannot be predicted or forged without the encryption keys, making the session hijacking impossible even if the attacker can sniff the network. Thank you.